morning and welcome to Vector or Scalar, the game show where the only question you have to ask is, does it have a direction? Today's contestant is from, which I'm told is very exciting. Now I'm sure you have all sorts of hobbies and interests, but I don't care about those. Let's play Vector or Scalar. Now as a reminder, a vector is a quantity that has both a magnitude and a direction, whereas a scalar is a quantity with a magnitude only. So if you want to decide the difference between them, you just ask yourself, does it have a direction? Here's an example. Force. Can you force something forwards or backwards, east or west? Yes, you can. Force has a direction, and so force is a vector. Are you ready to play? It's a bit late now if you're not. Here's your first quantity. Power. Vector or scalar? That is the right answer. Congratulations. Power is a scalar quantity. To say a power of 5 watts north makes no sense, and so it's a scalar. You've just won yourself £3.50. Here's your second quantity. Time. Vector or scalar? That is the correct answer again. Time is a scalar quantity. To say 2 seconds backwards makes no sense. You've just won yourself an all-expenses-paid trip to school to learn more about physics. That one was my idea. Here's your third quantity. Acceleration. Vector or scalar? Oh, that is the correct answer again. Acceleration is a vector. You can accelerate forwards or backwards, east or west. It has a direction. You've just won yourself a brand new helicopter. This one. Here is your fourth and final question. And this is for the jackpot. Today's jackpot is happiness for the rest of your life. The quantity is kinetic energy. Vector or scalar? Oh, that is the wrong answer. Kinetic energy is actually a scalar. The velocity that you have, that's the vector, but the energy that you have because you're moving, just like all energies, is a scalar quantity. It doesn't have a direction. Aww. You've just lost all of your winnings so far, and you owe me £10,000. Shame. Tune in next week to see if someone else can win our jackpot on Vector or Scalar. Good evening. Shut up! What if you wanted to add those vectors together? Well, to make this a bit clearer, I'm going to show you a short clip of myself on playground duty. Enjoy.
As you can see, my intimidating presence has frightened away all of the pupils, but as I enter the screen from the north, I find a pound coin on the ground and immediately twirl around in celebration, as you would. I then run southwards to share my finding with the rest of the school, but fall down and damage my ankle quite badly. I then proceed to limp westwards towards a first aid kit, which just so happens to be on the ground. The end.
Okay, let's analyse that playground duty in a little bit more detail. The story begins where I find, miraculously, a £1 coin on the ground. I then run 10 metres south to tell everyone about it, and that's when the tragedy strikes and I hurt my ankle quite badly, and you're obviously very upset. I then limp 5 metres westwards towards the conveniently placed first aid kit. Now let's look at distance and displacement first. To work out the distance that I've travelled is really easy, because distance is just a scalar quantity and therefore it only has a magnitude. You want to know the distance I travelled, just add 10 metres to 5 metres, and I travelled 15 metres in total. However, if you want to find my displacement, that's a little bit more tricky, because displacement is a vector quantity and has both a magnitude and a direction. My displacement is actually the straight line distance from where I started with the £1 coin to where I finished at the first aid kit. The magnitude of my displacement I work out by using Pythagoras. 10 squared plus 5 squared, which is these two sides, square rooted. The magnitude of my displacement is 11.2 metres. But remember, we can't stop there because displacement is a vector, so we also need a direction. To work out my direction, I need to calculate the angle next to where I started the journey. In other words, this angle here, x. I started with the £1 coin, so that's the angle I want to look at. And I work this out by using SOHCAHTOA. In this case, tan x is the opposite divided by the adjacent. 5 divided by 10. The angle eventually becomes 27 degrees west of south. Just make a little point on that. West of south is called that because I initially travelled south and then I veered west of the south line. Okay? If I'd gone east, I would have veered east of the south line, and so it would be east of south. Okay? But in this case, I started going south, and then I went west, so my angle has gone west of the south line. My final displacement that I would write would be 11.2 metres, magnitude, at 27 degrees west of south. Direction. We can also use this journey to talk about speed and velocity. So first of all, I need to know the time it took me to do both of these trips. Now, to go the 10 metres took me about 3 seconds. I obviously could go a lot faster than that, but I wasn't wearing the right footwear. And then I limped eastward or westwards, and that took me 6 seconds because I was injured, right? So my total time for that journey was 9 seconds. To find the speed is really easy. Speed is also a scalar quantity, and I just do my distance divided by the total time. In this case, 15 divided by 9, 1.7 metres per second. But my velocity is a little bit harder because velocity is a vector. Velocity is actually the rate of change of displacement. So I work out the magnitude of the velocity by doing my displacement, which stupidly has the symbol s for displacement, divided by time. And I get 11.2 over 9, which is 1.2 metres per second. But remember, velocity is a vector, so it also needs a direction. Thankfully though, the triangle here hasn't changed. My velocity and my displacement are in the same direction. So I can just borrow the angle I got from the last calculation to write my final answer. Velocity is 1.2 metres per second, still at 27 degrees west of south, west of the south line. Okay? Now, if you only want to take one message home from this video, it's that you still owe me £10,000. And if you think I'm joking, just remember, I know that your name is, and that you live at, think about that.